Hi, and welcome to Woodbridge Geometry Virtual Tutor. During this lesson, we're going to be working in the unit coordinate geometry, and we're going to be working with the objective when given 2 points or a set of coordinates, we're going to learn how to solve for the distance between those 2 points, the midpoint between them, and the slope between those 2 points. The first one we're going to take a look at is how do you find the distance between 2 points? You find the distance between 2 points using the following formula. The distance is equal to the square root of the second x value minus the first squared plus the second y value minus the first squared. Now, what do I mean by x2 and x1 and y2 and y1? When you are given 2 sets of coordinates, you are given a set of x values and a set of y values. You're going to have 2 x values and 2 y values. Now, to demonstrate how to use this formula, I'm going to demonstrate the following examples here. Now, one of the things I like to do is I like to label what my pieces are. What is x1 and what's y1? So I have -6 and -10 and -2 and -10. This would be x1, this will be y1, this is x2, and this is y2. So I'm going to plug them into the formula and find the distance between them. Distance is equal to the second x value, which in this case is -2, minus the first one. But I notice I'm going to have a double negative here, so this is going to turn into +6 squared, plus the second y value, which is -10, minus the first one. And I notice again, I'm going to have a double negative again, so it actually turns into +10 squared. Now, I just use the correct order of operations. I do parentheses first, and then exponents. -2 plus 6 is +4, and +4 squared is 16. -10 plus 10 is 0, and 0 squared is 0. When I add those together, I get 16 plus 0, which is 16. And the last thing I'm always going to do is I'm going to take the square root of that number inside. And the square root of 16 is 4. The distance between these 2 points is a distance of 4. With the second example, I'm going to do the exact same thing. This is x1, y1, x2, y2. To find the distance between them, I'm going to plug each of those into the formula and calculate. y2, which is -1, minus x1, which is 2, squared, plus y2, which is 4, minus y1, and I notice I have a double negative, so that's going to turn into +9 squared. -1 minus 2 is -3, and -3 squared is +9. 4 plus 9 is 13, and 13 squared is 169. When I add those together, I get the square root of 178. Now, when I take the square root of 178, it does not come out to a nice whole number. We get a long decimal. So make sure you pay attention to your rounding directions. And in this case, if we round to 1 decimal place, your final answer should be 13.4. When you're answering questions like this, you might get a whole number as your answer, or you could get a decimal as your answer. If you get a decimal as your answer, make sure you pay attention to the rounding directions. Now at this point, I would like you to pause the video, and I would like you to work on these you-try problems. If you happen to get a decimal as your answer, please round to the nearest tenth, which is 1 decimal place. Please pause, and when you are done, hit play and continue. let's take a look at these try problems now that you have completed them. So I want to find the distance between 6, 4 and -5, -1. So here's x1 and y1. Here's x2 and y2. So when I plug it into the formula, it should look like this. -5 minus 6 squared plus -1 minus 4 squared. -5 minus 6 is -11, and -11 squared is 121. -1 minus 4 is -5, and -5 squared is positive 25. And 121 plus 25 is 146. And the square root of 146 is going to be a decimal. So you should have rounded to one decimal place for a final answer at 12.1. That is the distance between those 2 points. For the second one here, here's x1, y1, here's x2, and here is y2. So when I find the distance, plug them into the formula, I'll have -1, this should have been +1 squared, plus y2, which is 3, and you have a double negative again, so this should have been +2 squared. -1 plus 1 is 0, and 0 squared is 0. 3 plus 2 is 5, and 5 squared is 25. And 0 plus 25 is 25. And the last thing I'm going to do is take the square root of 25, which comes out to a nice whole number, which is 5. Your distance here should have been 5. The next thing we're going to take a look at is how to find the midpoint between 2 points. To find the midpoint between 2 points, you're going to use this formula right here, which is x1 plus x2 divided by 2, and y1 plus y2 divided by 2. This is going to give you the location of the midpoint. So your answer should be another set of coordinates. So to show how this formula works, I'm going to demonstrate the 2 examples. Again, like the previous example, I'm going to label this is x1, this is y1, this is x2, and this is y2. So to find the midpoint, I simply take my x values and I add them together, and I'm going to divide by 2. Okay, and then I'm going to take my y values, add them together, so 7 plus 3, and divide by 2. -4 plus 8 is 4, and 4 divided by 2 is 2. 7 plus 3 is 10, and 10 divided by 2 is 5. So my midpoint is going to be 2, 5. So basically, to answer these questions, all I do is I add the x values, divide by 2, and add the y values and divide by 2. Taking a look at the next one, here is x1, y1. Here's x2, y2. I'm going to take my x values, which is 5 plus 2, divide them by 2. I'm going to take my y values, which is -6 plus 3, divide by 2. 5 plus 2 is 7, and 7 divided by 2 is going to give me a decimal. Now, it is a common practice that we just leave this in fraction form. 5 plus 2 is 7. We leave this as 7/2, or 7 over 2. -6 plus 3 is -3, and -3 divided by 2, again, is a decimal. So a common practice is we're going to leave it as -3 over 2. This is my midpoint right here. Now, when you are solving these kind of questions, your midpoint can be 2 whole numbers. It could be two fractions, or it could be a mixture of a whole number and a fraction. You could have the potential to see those three different types of answers. To find the midpoint between 2 points, you are to use this formula right here. At this point, I would like you to pause the video, and I would like you to try these two problems yourself. Please pause the video now, and when you are done, hit resume. Now that you have finished these you-try problems, let's take a look at this. I wanted you to find the midpoint between the following points. So the first thing I'm going to do is I'm going to label. Here's x1, y1. Here's x2, y2. I add my x values, which are going to be 6 plus a negative 3 divided by 2, and 4 plus a negative 10 divided by 2 after I add my y values. 6 plus negative 3 is 3, and 3 over 2 is, I'm going to leave it as 3 over 2. 4 plus a negative 10 is negative 6, and negative 6 divided by 2 is negative 3. So my answer is 3/2, negative 3. Here's an example of what a combination looks like where you have a fraction and a whole number. In the second you-try problem, x1, y1, x2, y2. I'm going to have negative 8 plus a negative 6 divided by 2, and negative 12 plus 6 divided by 2. Here is my setup. Now let's solve. Negative 8 plus a negative 6 is negative 14, and negative 14 divided by 2 is negative 7. Negative 12 plus 6 is negative 6, and negative 6 divided by 2 is negative 3. So my answer here, the midpoint is negative 7, negative 3. The last and final objective of this unit is to find the slope between 2 points. To find the slope between 2 points, you're going to use the formula y2 minus y1 over x2 minus x1. As you can notice, these three formulas use x1 and x2, y2 and y1. So that's very important that you start labeling them and know the difference between each three formulas. To demonstrate how to use the slope formula, I'm going to complete the following examples. The first thing I'm going to do is label. Here's x1, y1, x2, y2. I'm going to substitute in the values. Y2, which is 3, minus y1, which is negative 7, over x2, which is 8, minus x1, which is 6. If I do the math, 3 minus a negative 7 is really 3 plus 7, which is 10, and 8 minus 6 is 2. Okay. I can simplify 10 over 2 into 5. My slope here would be 5. In the second example, here is x1, y1. Here's x2, y2. I'm going to take the following numbers and I'm going to plug them in for their appropriate variables. Be y2 minus y1, which is 3 minus 1. And then x2 minus x1, which is 11 minus 5. 3 minus 1 is 2, and 11 minus 5 is 6. So I get 2 over 6. And one of the last things you should always do is simplify. 2 over 6 reduces down to 1/3. Your slope is 1/3. Your slope could be a whole number. It could be a fraction. To practice these items, please pause the video at this point and complete the following you-try problems. When you are done, you may hit resume and we will go over these together. Now that you have completed these problems, let's take a look at your work. Find the slope between the following points: x1, y1, x2, y2. Once I plug them into the formula, which is y2 minus y1 over x2 minus x1. Negative 12 minus 4 is negative 16, and negative 3 minus 5 is negative 8. Negative 16 over negative 8 reduces down to a positive 2. Your slope here should have been positive 2. For the final one, you have x1, y1, and you have x2, y2. When I plug them into the formula, it should have been y2 minus y1 over x2 minus x1. 9 minus 12 is negative 3, and 1 minus a negative 8, which is really 1 plus 8, gives me positive 9. Negative 3 over 9 can reduce to negative 1/3 as your final slope. That should have been your answer here, negative 1/3. I would like to thank you for taking your time and watching Woodbridge Virtual Tutor and going over the objective, how to solve for the distance, the midpoint, or the slope between 2 points. Thank you for your time.